Greetings, 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 and welcome to our next Big Ideas lesson, 3.1 in our Big Ideas book, page 104, where we are technically taking from the book the first set of notes from Unit 3, where we are going to be continuing to talk about angles and triangles. And today we're going to apply what we learned to find the measures of many types of angles, all formed by parallel lines when they are cut by a transversal. Ladies and gentlemen, our essential question tonight: how can you describe angles formed by parallel lines and transversals? So I believe in you. I know you are a person of character and intelligence. So I know you've already taken some notes, and that is absolutely fantastic. You've taken some notes, like the first set of notes you took on perpendicular lines. Two lines that intersect to form right angles we call perpendicular. Lines intersect at right angles. Right? So perpendicular lines intersect at right angles. I'm going to label this. This is going to be line R and line S. And I'm going to show you that line R is perpendicular to S. So this right here being the geometric notation, an upside down capital letter T is what they use to say, hey, line R and line S are perpendicular. And then, of course, you have parallel lines. You took some notes on parallel lines. Parallel lines, which what? Never intersect. Okay? And I'm going to label these line L and line M. And so the proper notation for that would be L is parallel to M. And so the parallel notation looks like an 11. And so line L is parallel to M, meaning they never intersect. And of course, then we have a transversal, which a transversal is just a line that intersects two or more other lines. That's all it does. Intersects two or more other lines. Now, we do have some special situations when we have parallel lines that are intersected by a transversal. That creates some very special relationships. And the first special relationship we are going to talk about is corresponding angles, formed when two parallel lines are cut by a transversal. Now, corresponding angles, there are one on the same side of transversal. They're on the same side of the transversal, and they are in corresponding positions. And you know about that. You know, because we've had corresponding parts before when we've been talking similar and congruent figures. So that should make sense to you. And so when two parallel lines are cut by a transversal, it does form four pairs of corresponding angles. One other thing we need to say about corresponding angles are what? They are congruent. They are congruent. All right? So let's take a quick look. Right here, we have this angle right here, and it corresponds to this angle right there. They are on the same side of that blue transversal line. Same side, and they are in corresponding positions. If you were to visually take one and put it on top of the other, they are in corresponding positions. We also have this one right here, this angle here, and this angle. They are on the same sides of the transversal, and they are in corresponding positions. And then you have let's go with an X right here. Those two angles, they are corresponding, and naturally, you have the last one. Use a check mark on this one. These two angles are corresponding. If corresponding angles exist, you know they are congruent. So now we're going to use what we know about corresponding angles to help find some angle measures. Ladies and gentlemen, finding angle measures. Using the figure below, find the measure of angle 1 and 2. So in looking at this picture, we are just going to assume that line L is parallel to line M. We're going to assume that, cut by transversal T. And we want to find what is the measure of angle 1 and 2. So we have this angle that's 63 degrees, and it just so happens it's on the same side and in corresponding part to angle 1. So angle 1 and corresponds. I want to write corresponds here. Angle 1 corresponds to 63 degrees. So angle 1 has to be 63 degrees because corresponding angles are congruent. And then we go to angle 2. Well, angle 1 and angle 2, what do you remember about that relationship? They're side by side. They share a vertex and a side. They are supplementary. Meaning they equal 180 degrees when you add them together. So I'm going to call angle 2 x, and I'm going to go x plus angle 1, which is 63 degrees, equals 180. So x equals 117 degrees. So angle 2 equals 117 degrees. So angle 1 is 63 because they're corresponding. Corresponding angles are congruent. And angle 2 is 117 because it is supplementary to angle 1. Moving on. The same type of figure. Here we have A and B, and we're going to assume that A is parallel to B, cut by transversal T. And we again want to find the measures of angle 1 and 2. And this 99 degree angle corresponds to angle 1. So angle 1 corresponds to 99 degrees. So angle 1 equals 99 degrees because corresponding angles are congruent. We also know that angle 1 and angle 2 are supplementary, meaning they equal 180 degrees. So I'm going to call angle 2 x again. X plus angle 1, which is 99 degrees, equals 180. So x equals 81 degrees, meaning angle 2 is 81 degrees because it is supplementary to angle 1. Pretty straightforward, eh? Let's try this one more time. A little bit more complicated because we're going to use this figure to find the measure of all the numbered angles. And again, we're going to make that assumption. They should tell us that they didn't, but I'm going to tell you A is parallel to B, cut by transversal T. And so let's just start right away. The only angle we know is this angle right here, 68. Now we've learned some angle relationships. Let's use the first one we just learned in this video, and we're going to go right here. So angle 6 is 68 degrees because it corresponds. Right? It corresponds to 68 degrees. Now I'm going to go angle 1. Tell me what angle 1 is. Yeah, angle 1 has to be 68 degrees. Why? What relationship did we learn in our previous video when we reviewed? That's right, it's vertical. It's vertical to 68. This one corresponds to 68, right? And then we can do angle 4. What's angle 4 have to be? That's right, angle 4 also has to be 68 degrees. Why? Well, angle 4 is vertical to angle 6. And we know angle 6 is 68 degrees. All right, so we know that what angles 1 and 6 and 4 are. Let's see what else we can do. Well, we can find angle 2. I'm going to change colors now. Angle 2. What does angle 2 have to equal? Well, angle 2 has to equal 112. Why? Supplementary to 68. So right here, angle 2 is supplementary to 68. And then we can say angle 3 is also 112. Well, why is that? Vertical to angle 2. And then we have angle 7. Angle 7 is 112. Why is that? Corresponds to angle 3. And then angle 5 is also 112 degrees. And why is that? It corresponds to angle 2. So a lot of things that we know that we can do based on all the angle relationships that we've now learned. Specifically in this one, 2 parallel lines cut by a transversals does create 4 special angle relationships, all being corresponding, and corresponding angles are congruent. Ladies and gentlemen, that ends our first video. I gave you the handout, so go ahead and find what are the measures of all of the numbered angles. Take a quick break and come back and join us for the second video tonight.